listening to the Shared Security Podcast with Tom Eston and Scott Wright, exploring the trust you put in people, apps, and technology.
And now a word from our sponsor, Edgewise Networks. Organizations' internal networks are overly permissive and can't distinguish trusted from untrusted applications. Attackers abuse this condition to move laterally through networks, bypassing address-based controls to spread malware. Edgewise abstracts security policies away from traditional network controls that rely on IP addresses, ports, and protocols, and instead ties controls directly to applications and their data paths. Edgewise allows organizations to analyze the network attack surface and segment workloads based on the software and how it's communicating. Edgewise monitors applications and protects data paths using Zero Trust segmentation. Visit edgewise.net to get your free month of visibility. Hey everyone, welcome to this special YouTube edition of the Shared Security Podcast. And joining me today is Adam LeWinter, who's a solutions architect with Edgewise, and he's going to be going over a demo of the Edgewise product. Welcome to the show, Adam.
Yeah, great. Thanks for having me.
Glad to have you. So maybe for our listeners that may not be familiar with Edgewise or your product, could you give a brief overview of what you guys do and what's the solution that we're about to see?
Yeah. So Edgewise is a zero trust segmentation company. What we do is we combine the idea and methodology of zero trust to microsegmentation. And so those that are unfamiliar, zero trust is the concept of not inherently trusting anything just because you've seen it previously. Just because a web server was trusted before or a few days ago or even a couple milliseconds ago doesn't mean that you can trust that now at the current state in time. So bringing that into the concept of microsegmentation, where you only want to allow certain things to communicate on the network that you know and you trust, and nothing else, to really the concept of least privilege access. Kind of the marriage between those two is really what our platform is all about.
Yeah, that's great. And for anyone that wants to get a lot more detail into, the history of the company or, even more technical details around how the product was developed, we have a great interview with Edgewise CEO and founder, Harry Swerdlove. And that is available for you to download and check out on YouTube. And of course, the regular edition of the podcast. So.
Yeah, absolutely. He's a wonderful technical resource.
He is. He's super smart, and he's got a fascinating background in cybersecurity that we found out, especially since he used to work at McAfee, the old McAfee.
Yeah, yeah. No, he's a wealth of knowledge that I learn something new from every day. So definitely a good resource for anything security related.
Definitely. So. Well, why don't we get into a demo of the product, and then Scott and I can maybe ask you a couple questions while we see it.
Yeah, great. So before we jump into looking at the product itself, I think it helps to think about how one would approach microsegmentation as a project. It's often thought of as being something that's very complex and hard to implement. So what are some of the things that we would need to do in order to successfully do this without having multiple full-time employees dedicated multiple years to do this? So here at Edgewise, we are an agent-based solution. So what this means is that you would install our agent in any way that you feel comfortable. So typically with our customers, that's going to be through deployment tools like SCCM, Puppet, Chef, Ansible, and the like. Edgewise will provide you automatically an inventory of the software, the hosts that software is running on, and the networks on which that software communicates. And what we're doing is auto-discovering how software from those individual servers are communicating. And so this is actually one of those unique points to our company and our approach here, is that not only are we providing this information in this topology map, or you can think of it as an ever-breathing and living diagram of your network, it's actually the way that we enforce our policies. So we are not a traditional network control like a host-based firewall or a traditional network firewall, whether it be next-gen or not. It's more about the idea of we want to tie policy to the true software's identity rather than tying it to how that software communicates. So what we want to do is first understand then what we have communicating. And that's what we do here with this inventory. So if you think about microsegmentation as a broad concept, it's pretty simple. Step one is you create a segment. So you group something together and say, this is my boundary. I'm going to default deny everything that to and from that boundary. But then step two is I'm going to then choose what software, what hosts, what entities can traverse that boundary. So, pretty simple. But in practice, that gets a lot more complicated, especially when you look at doing it in a truly secure manner with the zero trust approach. You can't simply say, oh, I'm going to block this port and this protocol, or allow this port and protocol through. Because if you start defining it at that level, you don't actually know who's behind that communication. You're defining a policy on how something's communicating, not a policy on what is communicating, which is truly the idea that we want to get to with microsegmentation in a zero trust methodology. So to do this, we want to be able to first understand the groupings that we need in our environment to first create these segments. And so step one of that is to create host groupings, or groupings of physical servers. And so what we do here at Edgewise is we utilize a machine learning data analysis process that recommends those groupings for you. So we come over here and look at our collections that we have. We have a listing of all of the different types of databases and servers that we have in our environment that have been grouped together as seen by the machine learning. And so what it's really doing is looking at how things are behaving, what are the commonalities and communication patterns, and grouping those together in ways that make sense for the environment. So I can see that I have a group of development databases, I have a group of load balancing servers, I have my desktop network. All of these are picked out by that machine learning and recommended to me as these groupings. So that gives us that host level segment, which is great. That's what we need. But that doesn't get us all the way there, right? We obviously start to need to create policies to make that segment into a perimeter. So what we're going to do, and what we'll see here shortly in the product, is we will create a default deny on the host segments that we see here on the screen. That's going to allow us to say, hey, by default, nothing's allowed to communicate in or out of this grouping, this segment. That's step one, right, as we discussed before. Step two then is, okay, we now need to be able to define what is the exception, what is allowed to traverse that boundary, whether inbound or outbound. And rather than focusing on host groupings to being able to do that, we want to move on to the idea of application groupings. So focusing on the workload itself, focus on the fact that, okay, we have some load balance servers, but first what we want to do is understand what's running on those load balancer servers to actually do the process of the load balancing, because that is what we want to protect. We want to reduce the attack surface of these servers by only allowing through that which is needed, that process that is doing the functionality that we expect from the business application. And I have an example of that here with our login services. So we have our login servers or hosts that can have things like, if it's Windows, RDP, it can have your LSAS process to talk to your Active Directory. It can have any type of printing services, all of these different things that are out there that are running on this host, these individual executables that communicate on the network. But what we want to focus on for this perimeter section is just the pieces of software that need to communicate, which in this case will be the login services. So that's going to allow us to create not just exceptions based on where something's coming from, but based on what it is.
I have a quick question.
Yeah.
What does so Edgewise, the product actually collects all that information from the network, right? And then it populates the dashboard I'm seeing?
So actually not quite. We're not looking at packet data, which is what you can get on the network. We're looking at attributes of the software that we get through our agent being present on the hosts. So for us, true identity is not simply identifying how something's communicating, which is what a standard 5 tuple will give you. We're focused on understanding what is sending or receiving that communication. And to get to that level, we need to be on the hosts themselves to be able to collect the data about the true identity of that software, that service that is sending or receiving the packet. And so we are actually collecting our data not from the network, but actually from the instantiating software that's trying to create the connection.
Yeah, and I think that's a good distinction that needed to be said, because I think a lot of people, when they first see this, they automatically think, oh, it's just, pulling packets off the network and determining this. But that's what makes, your solution a lot different, is the host-based piece of this that is actually, doing that work up front.
Yeah, absolutely. So once we have that data, we then use the machine learning to group it together based on how those individual pieces of software are communicating. And so if we start from, say, our database services for our production environment here. So we're going to start with the production databases. This is my host collection that we talked about, that host segment. We come in here and look about how this is defined. We'll see that it's actually every host in the environment that is running a database. And for us, the nomenclature, the naming convention is we have DB in the name. So I can understand that these are all my database servers. Okay, well, you can see that each of these have, say, 26 different pieces of software running on them, talking on the network. This one has 9, this has 27. What we want to focus on is the actual database process itself. And so for this environment, we actually run Mongo database. So instead of focusing on the database host, I'm going to focus on the actual Mongo process itself. And so when we look into this particular collection card here, what we'll see is that this is pulling out the Mongo database process, the daemon, running on the production databases. So we're now overlaying an application segment on that host segment, which is getting us to that real micro segmentation. We're putting the protection as close to the application workload as we can, because we're now focusing on just the application that's running. So what happens when we dive in and look at this? Well, let's view the connections of that production instance, those production instances of the Mongo database. So what we see here are different communications happening between the segments that the machine learning has recommended for us. I can see that my production Mongo databases are being communicated with by the login services, by the order services, by a couple different things that make up this application. And what we're actually looking at here is an e-commerce application. So when we come in here, we look at we see the production Mongo segment that we've selected. On the left-hand side is everything that's talking inbound to it. So we can see that there's a couple different styles of things in here, or different segments that are communicating across, one of which is my login services. So login services then are being communicated with by some front-end services that are then being communicated with by a load balance service, which is then being communicated with by the global internet. And so what I'm able to see here is an entire pathway of communication in terms of how my applications function to provide a service for my users. In this particular example here, it's the globally unmanaged internet talking inbound to our load balancer services, talking then to our front-end services, which are talking to the login services, which are then going to the database. So this is how users would log in with to my e-commerce environment. Now, what's really interesting about this is that this was all auto-discovered. This was all automatically created. You didn't have to actually come in here and define anything. The machine learning was able to define these groupings, and then the automatic nature of how we're watching communications on the network, we were able to display all of this for you and show you that this is how this is how those services are making the login functionality of the e-commerce site work. So it's as simple as that. Edgewise provides you an understanding of how your environment should be segmented based on the behavior and the communications we see. And we're providing you a full mapping of how those services interact to create a functionality of your environment that is required for the business.
I have a question for you, Adam.
Yeah.
So yeah, I mean, that's a really nice way to lay things out. I was wondering, so now does each element or each node there have the ability to literally control traffic going through it? Like, do you have the ability to put rules on them?
Absolutely. And that's when we move into this, secondary phase idea of what we talked about in terms of how you do microsegmentation. The first is to create your segments. Now we're going to define what can traverse those segments. And so the first step of that,
cool.
Yeah, the first step of that is to simply do a default deny. I'm going to, by default, deny everything. Now, that creates the perimeter, right? That's the hard line of unless you are allowed through, you're blocked. Now, what is that going to mean? Well, I can simply come down here and say, well, my login services are supposed to talk across to the database. So let's go ahead and do that and turn that just to improve. My order services need to talk to the databases as well. So I'm going to go ahead and approve that. And what I'm doing here is applying policies at the segment level. It's important to note that the policies I set at the segment level are going to be inherited by everything inside of that segment. So when I say the login services here are allowed to talk to the databases, I'm not saying these hosts are allowed to talk to the database. If we expand this a little bit and look at what the details are, I'm saying this individual login service is allowed to talk to the databases. And the way that we do that is by applying the policy, once again, not to the IP port and protocol, but to the actual identity of the software, as we see here. So this is what's happening under the hood, but now I'm managing this at a level that makes sense for me as a practitioner. I know my login services need to talk to my databases. I know my order services need to talk to the databases. From the login service side, I know that my front-end services need to communicate, and my order services need to communicate to talk to understand information about tying the orders to the actual users that they're going to ship to. But nothing else needs to. So let's go ahead and set that other perimeter up. And as you can see here, as I go through this process, I'm building perimeters on each of these segments. I'm saying let's default deny everything to start, and then I'm going to define my exceptions. And the exceptions of what I'm allowing through are being applied to the software that needs to communicate across, not just the host as a whole. And that is the fundamental difference of Edgewise versus other network type controls. And that also means we're going to be able to prevent those types of attacks that are common to get through firewalls, such as protocol piggybacking, where I pretend to be a valid application by communicating in the right way, thereby bypassing whatever controls the firewall will have. With Edgewise, it's based on the identity of the software. So even a zero-day attack or any type of admin tools that you would use, like MySQL admin tools to talk to a MySQL database, or PowerShell, or SSH, will not be allowed to communicate across, even with valid admin credentials, because it's not trusted software. And that's a key point here. This is how we are applying zero trust to microsegmentation. It's all about understanding the identity of that software and only allowing through that which we trust and that which we can validate the trust on, thereby stopping that type of zero-day attack.
So let's take, for example, there's malware that's installed on that same server. What you're saying is that malware would not be able to communicate or propagate because of the policy that's set on that, right? On that
exactly.
system.
The policy set says only the software that we can identify as the valid business application is allowed to communicate. That malware, no matter if it mimics the communication pattern or not, will not be allowed through because its identity is not validated as trusted software.
So does this mean that you'd probably have similar skill sets of people who are administering the Edgewise software as would be administering, for example, firewalls?
Exactly. And so the idea is that you would need either the same amount of people or even less. We have a couple instances of some of the customers in the financial or legal spaces that have actually been able to reduce the number of people required to manage their network security by using a tool such as Edgewise, because we focus on the idea of using machine learning and automation to group this together in intelligent ways to give you the ability to set this up. And that same machine learning also helps us to handle dynamic environments. So where you have constant change, auto-scaling up, auto-scaling down. If you remember how we defined these segments, they're defined by what's essentially a saved search. It's a search string that you need to match. Anytime that we see a matching entity in the environment, whether it be software or server, that means it's automatically going to be added into the segment and inherit any policies that we put on that segment. So as an example here, during the holiday season, perhaps my e-commerce site is going to see a lot more traffic, which means I need a lot more of my front-end servers to be running in their load balance cluster. With Edgewise, I've already set the policy in place of what's allowed to communicate with them and how they're allowed to communicate out onto the network. We can see here I have all of these individual auto-scaled instances of the front end automatically in here. So where we set one policy, it's automatically going to apply to every instance that we need as this scales up and down, without me as the practitioner having to do anything to change it. So that means that as the dynamic nature of my environment progresses, I as a practitioner don't have to come in here and constantly make changes. So we free up time and required to manage this type of tool by automatically handling those changes for you, by designing our platform to work in the dynamic nature that your solutions do. So it's going to very much be the same amount of time or even less than what you're used to with your traditional firewalls.
So you might even have like in the firewalls protecting the sort of lower level network, you'd probably have a lot simpler set of rules then, right?
And that's a great point. So everything we've just done here to set up this pathway of communication of what's allowed, we defined in 8 policies. So we can see here when we look at the policies that I have on my production Mongo environment, I have my default deny, and then I have allowed through my login services and my order services. And I can see that as I can continue down here, same thing for the login services. I put a default deny, allowed through just those that are needed, and the front-end services the same way. So 8 policies has been able to completely protect the login functionality and the user's service functionality of my e-commerce application. This is not dependent upon subnetting, VLAN, where this is. And that's another key point. For our software, it does not matter where, that's another key point. For our platform, it does not matter where the software lives. These load balancers could be in AWS. The front-end services could then be in Azure. The login services could then be in Google Cloud Platform, and the databases could be sitting on-prem. The location does not matter to us, and I could then move these around. I could be in the process of migrating from on-prem to the cloud. The policies do not have to change because they are tied to the identity of the software, not to its physical location based on IP, port, and protocol. So that's going to allow us to handle not just the auto-scaling dynamism of an environment, but or any type of migration that you might be going through.
Another question, is there any type of alerting if there were processes that were trying to, say, spawn and, do things that they're not supposed to, like a potential malware infestation?
Absolutely. So as part of that machine learning process of creating these groupings, we are actually taking the SHA-256 hashes of all of the software that we see and running them against the 65 multi-scanners that are out there, from the likes of your CrowdStrikes to your Carbon Blacks to your Cylances, and understanding what do we know about the reputation of this file. If we have software that is known to be malicious, well, first of all, we're not going to recommend that you put those into a grouping. And second, we'll call those out for you. We'll show you that, hey, this is something that you probably want to take a look at. Now, from the standpoint of what happens if I have a policy violation, right? What happens if I actually have to enforce a block? Whether that be because I have something malicious happening, or because I have a user attempting to connect in some way that they normally didn't before, or maybe I made a mistake or something's changed and I need to update the policy. That's where we have this monitor section for. So once I've applied these policies, we are actually showing you every time that the environment is going to take an action. So that's where we come to the monitoring section here. Every time that we have an Edgewise policy that is enforced, we will tell you the source host, the source application, the target host, the target application, and what was the event? What did we decide? What was the result of the enforcement? Selecting on any of these will show you exactly what policy was enforced. And not only that, but where was it enforced? Was it enforced on the destination side or on the sender side? So this is a way for us to understand not just, hey, I have a policy or a block occur, and I have to go dig in and find out which policy it was in my hierarchy of all the policies that I have in place across my entire environment. This will simply point out exactly what policy was enforced. So if I need to make a change, I can simply come in here to my diagram and make the change. Now that was an allow. We also do that for blocks. So the last thing that we want to understand when looking, towards the idea of alerting or towards understanding the state of the environment is what policies are in place. So that means I can simply come over here to the catalog section, look at my policies, and see what I have that's active in the environment. So the other part here then is when we come to the catalog and policy set, the catalog policy section here, we see everything that we just did. All those policies we just applied and created are listed here for us. So I can see what's on the inbound side, and there's those policies that we looked at. I can filter to look at just my default denies. I can filter to look at my allows. And so this shows me what is currently active in the environment, what policies are actively in place, which can be very helpful for any type of auditor event or any type of proof that you need to show that, hey, how are you protecting this environment? Here's exactly how. And the monitor section then is the result of that.
Yeah, that was going to be one of my questions is, from a reporting perspective, because, we all love auditors. How would they view information about how the systems are protected? And I think that, is there any other additional capabilities around reporting?
So one of the key things about all of this is our entire service is built on APIs. So all of this data is available to be exported to any analytics platform, any SIM, any other type of platform that you need this to go to be able to aggregate data for an audit, to understand context around what the network was doing during an incident in an IR situation. So it doesn't require you to be just inside of our tool. You can actually get this data to enrich other platforms that you use.
Nice. And is the console itself, is that all cloud-based? It's not an on-prem, right?
Yeah, absolutely. So our entire architecture in terms of our backend is hosted as a SaaS solution. So the only thing that you require, or the only thing that you are required to install on your side is the agent itself. There's no aggregator. There's no proxy that's required to be connected across or connected up to.
And the agents would update themselves, I imagine, over time?
Yeah, the agents can be set to update themselves, or you can also set them to be updated manually if you have a very strict change control process.
And nice overview.
Yeah, we're really excited by the idea of the marriage between Zero Trust and microsegmentation into this Zero Trust segmentation concept and platform we've built here. And we're seeing a lot of customers understanding that value and starting to become successful with it.
Yeah, it's great. As I mentioned to Harry in our last interview, you guys are really doing some innovative stuff here, and frankly, it's a game changer in the industry. So it's really good stuff to see, the demo and see how it works. And I think our listeners would really appreciate the demo.
Yeah, my pleasure.
If our listeners are interested in finding out more about Edgewise or purchasing the product or talking more, what do you recommend they do, or where can they go?
Yeah, the best way to do that would be go to our website at edgewise.net, and there is a contact us form there that you can reach out to myself and the additional sales team here.
Well, hey, thank you very much for taking the time, and we really appreciate it.
Yeah, I really appreciate the opportunity to come and discuss what we're doing here.
Awesome.
Great.
Excellent. Thanks a lot, Adam.
All right, guys.
Have a good one, guys.